linear algorithm to do the walking, and then you're going to have throwing things back in the tree. So in essence, we're kind of doing a sort in a way that's n log n, which kind of makes sense because that's how sorting algorithms typically work, right? Is n log n. Okay. Any questions about that?
So the data don't have to be unique, right? It can be doubles or whatever, like repeated, and we do the
Well,
same
we
thing.
talked about the problems with that, right?
Right.
Yes, the data it'll be fine no matter what, because when you do the recursive in order traversal, you're going to get them in order. And if there are dupes, that's fine. It's going to come out in the wash and be fine. For this purpose, the dupes don't cause us any additional grief. And in fact, when they go back in the tree, it's a good question, but I think we'd see that they'd probably be more together in the resulting tree as well, right? But yeah, dupes don't cause us any additional grief here. All right, any other questions about that? So if you're doing the extra credit, then that's the approach that you would take, right? You would do exactly this kind of thing. The other thing that's interesting to think about is with our particular project, what happens with the dupe nodes, right? What happens with that chain of dupes, and do they affect the whole balancing thing of the tree? What do you think? I agree.
You mean what we're doing with the dupe in this project, or what? I don't understand the question.
I'm sorry, Idris, say that again.
You mean what are we doing with the duplicates in our project right now?
No, I'm saying if you were doing this rebalancing project, if you're doing the rebalancing for the extra credit, do you care about, what do you do with the dupe nodes in terms of this rebalancing? And the answer is you don't worry about them. Because if you're clever, what you do is you rebalance based on the nodes, not the data. And if so, those things go along for the ride. Remember, they're actually not part of the tree structure, right? They're not part of searching. They're not part of contains or, add. They actually don't participate in a lot of the standard kind of tree searching stuff. So actually, if you're clever, you're doing the rebalancing based on putting nodes back into the tree. So you're building it a little differently than you were with just data. And therefore, the dupe nodes don't count, right? They're just hanging on, and they don't appear in the counts for this. They don't even go into the array because they're just going along with the node. When you throw the node into the array, all of those little things are hanging on, right? They're hanging on to the array. So you actually just can walk the tree and not even worry about the dupe nodes, as long as you pay attention to the fact that you're going to be working with nodes in your rebalance rather than the data in the rebalance. Okay, does that make sense? There's some interesting generic challenges with doing that with nodes, but you can follow that and it will make some sense. Okay. All right. Any questions about that? Okay.